Hey,
Yo.
Monaco and Milks. We're going to name some covalent compounds. And so if naming ionic compounds was not your jam, covalent compounds are easier. Using nomenclature rules is really simple.
Yep.
We can get the formulas and the names, but the thing is we got to memorize something new. Yeah. This is not in our reference table. So
no, these prefixes, they're not anywhere to be found.
Yeah, so the pattern is the nonmetal, then nonmetal for covalent compounds. Correct. So the first nonmetal gets its name said. The second nonmetal ends in "ide," just like ionic compounds. But Correct. The problem is we got to put prefixes in to tell us the number of each atom. So in my personal opinion, naming covalent compounds is a lot easier because all you got to remember is how many, and then how many is the subscript given to you in a formula.
So let's give you the prefixes real fast that you got to know, and these are all of them. So I'm just going to list them all out there. Most of them we know till tetra. Tetra's a little weird. Even octa's one we should know.
Yeah.
Right? So we'll give you a second, write those all down. But again, one last time, these aren't in your reference tables. You've got to memorize these.
Yes.
So
if I'm talking about 3 atoms of chlorine, it would be trichloro.
Right.
Something. And you'll see that as we go. So are these fully animated? Oh, yep. Yes, they are.
Yeah.
So the first nonmetal says its name, carbon.
Carbon.
The second nonmetal gets a prefix, mono.
1 oxygen, mono.
Ox for oxygen, ide. Carbon monoxide. End of story.
Right. Notice there's no mono on the first nonmetal. We never say monocarbon monoxide.
It would be redundant.
Too much. So again,
carbon, not monocarbon. 2 oxygens, ide. Carbon dioxide.
Again, no mono on the first nonmetal. Now, this next example doesn't follow that because there's 2 hydrogens. So it's dihydrogen. How many oxygens?
Mono. 1.
Monooxide. Dihydrogen monoxide.
Or monoxide. Yeah.
Monoxide.
That's it.
That's right.
So we're using the subscripts to tell you how many we're in.
It's really that simple. And we go forwards and backwards.
Yep.
So can you tell me what this one's going to be before you see it?
Diphosphorus trioxide.
Diphosphorus, you're right.
I can count in Latin or whatever these prefixes are from.
Yeah.
Greek, Latin, who knows?
Right. Yeah.
German. I don't know.
How it goes.
That's how it is.
So that was that way, and I think next we get to go backwards.
Yes. So, easy. Carbon. That means there's 1 C.
1 carbon.
Tetrachloride. Tetrachlor. So tetra means 4. Chlor means chlorine. So 4 chlorines.
So chlorine and 4. Perfect.
There it is.
That's simple. Nitrogen. Trihydride. That's a little tough, but that HYD is hydrogen.
Yep.
So it's right.
Hydra and 3 for a tri.
Gotcha. Simple.
6. Sulfur difluoride. Fluoride's F and di means 2, so there's F2. SF2.
Done. See, he really likes this.
I do.
He does really.
Every topic's my favorite topic.
Well, this is true. How many favorite atoms do you have?
118.
Nitrogen, but it says di, so I need 2 of them.
Yep, N2.
And then oxygen, it says tri, but I need 3 of them.
N2O3.
Done. We just did a whole video.
It kind of makes up for running out of 5 seconds.
Yeah, should we draw real quick for him?
N2O3.
Was
N2O3. No, I don't care. Do N2O3 right here.
The last video.
We taught him how to do it. Do N2O3. Yeah, he's doing my method.
Oops.
This is bonus materials.
I got excited. So here we go. I got a bond. And then here I go. I got a bond. And then here I go. I got a bond. And then here I go. I got a bond. And here I go. I got a bond. It's going to look like N bonded to an N. Double bonded to an O. Double bonded to an O.
Look at those Lewis dot diagrams.
Dude,
it works. The visual method works.
Oh, I had no idea I could do it.
He can. It's actually pretty simple. It is. So that's it. That's all, folks. See ya. I'll take the button, turn it off.